Welcome back. Now we will start with block 4, that is forecasting methods. Again, this consists of 4 units, that is business forecasting, correlation, regression, and time series analysis. We will be starting with business forecasting. In today's highly dynamic business environment, managers have to focus the future and design strategies accordingly. The success of business depends mainly on future planning based on past and present experiences. The experiences may be quantitative and or qualitative. Both these type of information help managers in business forecasting. Managers use forecasting the art or science of predicting the future techniques to make strategic decisions about selling, buying, hiring, etc. every day. The past data are used by managers to make predictions about the future. Forecasting is essential in order to make reliable and accurate estimates of what will happen in future in face of uncertainty. A chart of the forecast and the decision making process is here. You can see that strategies you have to think of forecast. These all activities are interconnected. See the first loop: forecast, strategies, decisions, planned performance, monitoring system, divergence, and DC and manufacturing systems are related to actual performance. These reasons are also get influenced by the additional information obtained by using the forecasting method. Such information and the perceived accuracy of the forecast may also affect the strategy formulation of an organization. Thus, an organization needs to establish a monitoring system to compare planned performance with the actual. Some of the objectives of forecasting are creation of plans of action, because it is not possible to evolve a system of business control without an acceptable system of forecasting. Monitoring of the continuing progress of action plans based on forecasts. Third one is the forecast provides a warning system of the critical factors to be monitored regularly because they might drastically affect the performance of the plan. Distinction amongst or between prediction, projection, and forecasting. These three words seems to be same. Now we will see how much similarity they have. Prediction is a future estimate based on extrapolation. Hence, prediction is solely based on past data of the series under investigation. A projection is a prediction where an extrapolated value is subject to certain assumptions. And a forecast is an estimate for some future point of time, partly based on past and present data, and partly on subjective estimates arising out of the experience and judgment of the forecaster. What are the steps in business forecasting? First of all, we have to know the cause of change in the past. While attempting to forecast business fluctuations, a clear understanding about the causes responsible for the past changes is must. to measure the phases of business activity. Having known the cause of occurrence of fluctuations, certain phases of business activity needs to be computed so as to forecast the changes, which are supposed to occur after the current level of activity. Third one is selection and compilation of data. The business barometers forms the basis of statistical data available for measuring the fluctuations in business activity. Fourth one is analysis of data. The data needs to be analyzed in the light of one's understanding of the reasons why changes occur. If it is known that certain factors have resulted in a given change, then these factors are to be computed statistically to draw conclusions about the future. What are the methods of business forecasting? The methods of forecasting can be classified into two broad categories. The first one is quantitative or objective, and the second one is qualitative or subjective. These can further be divided into several methods. We'll see what are these methods are. Quant- Qualitative forecasting methods. These methods consist of collecting the opinion and judgment of individuals who are expected to have the best knowledge of current activities or future plans of the organization. An important advantage of qualitative method is that they are easily understood. Another advantage is that they can incorporate subjective experience as inputs along with objective data. Again, the cost involved in forecasting is quite low. These methods have some limitation. One serious limitation is that varying perception of people involved in forecasting. Some might say this is correct, some might say this is correct. But conclude. As a result, intuitive forecasts are likely to differ from one individual to another, and wide variance is found in forecasts. These methods are which have a limited number of customers. Personal opinion. Here, an individual does some forecast which can be relatively reliable and accurate of the future on the basis of his or her personal judgment without using a formal qualitative model. This approach is usually recommended when conditions in the past are not likely to be held in future. Panel consensus. To reduce the prejudice and ignorance that may arise in the individual judgment, it is possible to develop consensus among the group of individuals. Such a panel of individuals is encouraged to share information, opinions, and assumptions to predict future value of some variable under study. Delphi method. This method is very similar to the panel consensus method. In Delphi method, a group of experts who may be stationed at different locations and who did not interact with each other is consulted. After this, a questionnaire is sent to each expert to seek his opinion about the matter under investigation. A summary is prepared on the basis of returned questionnaire. On the basis of this summary, a few more questions are to be included in the questionnaire, and then this modified questionnaire is again sent back to each expert. This process, which generally keeps them informed of each other's forecast, is repeated until the desirable consensus is reached. The Delphi method is an iterative procedure. in which inward revisions are carried out by the experts till the coordinator gets a stable response. This method is very efficient if properly conducted, as it provides a systematic framework for collecting experts' opinion. By virtue of anonymity, statistical analysis and feedback of results, and provision for forecast revision, results obtained are free of bias and generally reliable. Next one is market research. The market research method is introduced in order to collect data, and accordingly a well-designed questionnaire is prepared and distributed amongst the respondents. On the basis of response obtained, a summary is prepared and the survey result is developed. Quantitative forecasting methods. These forecasting methods can be used under the following situations. Past information about the variable being forecast is available. Available information can be expressed numerically. A reasonable assumption is that the pattern of the past will continue in the future. Forecasting for medium and short-term decisions. Forecasting for the medium and short-term horizons from 1 to 6 months ahead is commonly employed for production planning, scheduling, and financial planning decisions in an organization. We can classify these methods into five categories: subjective or intuitive method, methods based on an average of past data, that is, moving average and exponential smoothing, regression model on historical data, casual or econometric model, stochastic model with time series analysis, and box Jacobson model. First of all, that we will start with subjective or intuitive method. These methods rely on the opinion of the concerned people and are quite popular in practice. Top executives, salesmen, distributors, and consumers could all be approached to give an estimate of the future demand of a product, and a judicious aggregation adjustment of these opinions could be used to arrive at the forecast of future demand. Committees or even a Delphi panel could be constituted for this purpose. However, all such methods suffer from individual bias and subjectivity. It cannot be documented and programmed for use on a computer so that no matter whether A or B or C makes the forecast, the result is the same. However, subjective and intuitive methods have their own advantages. Marketing or other functional areas may be the only method available to forecast and plan future operations. Methods based on averaging of past data. Exponential smoothing method. Exponential smoothing is another technique used to smooth a time series of its sharp variation. It is a type moving average forecasting technique which consists of a series of exponentially weighted moving averages. The exponential smoothing method weighs data from the previous time period with exponentially decreasing importance in the forecast. This method has a relative advantage over the methods of moving average. First, this method focuses upon the most recent data. Second, during forecasting, this method takes into account all the observed values because each smoothing value is based upon the values observed previously. This method is used for forecasting when there is no apparent trend or seasonal variation in the given value of a variable. However, this method is useful mostly for short-term forecasting, like forecasting of sales, inventory, price, etc., where alpha is a smoothing constant and that is the relation. Normally, this is the relation what we use in this phenomena, that is Ft is equal to alpha d1 plus 1 minus alpha Ft minus 1. That depends upon the value of alpha, D, demand and forecast, where alpha is a smoothing constant that lies between 0 and 1, but generally chosen value lies between 0.01 and 0.30. A higher value of places more emphasis on recent data. To initiate smoothing, a starting value of Ft is needed, which is generally taken as the first or some average demand value available is the problem. Another method often used in time series analysis is to identify the following four major components in a time series. That is secular trend, which is long-term growth in the market. Cyclic fluctuation, that is due to the business cycles. Seasonal variation, that is woolens where demand is seasonal. And random or irregular variations. Now we will see the combination. Okay. Your unit 14 is correlation. What is the meaning of correlation? Correlation refers to the association between two variables. When an association exists between two variables, it means that the average value of one variable changes as there is a change in the value of the other variable. A correlation is the simplest type of association. When a correlation is weak, it means that the average value of one variable changes only slightly or only occasionally in response to the change in the other variable. If there is no association, it means that there is no change in the value of one variable in response to the change of the other variable. In some cases, the correlation may be positive or may be negative. A positive correlation means that as one variable increases, the other variable also increases. That is, the best example to understand is as the age of a child increases, his height also increases. Negative correlation, it implies that one variable increases, the other variable decreases. The best example is the depreciation of the value of the car. You purchase a new car, after 1 year, it will be depreciated and the value will be reduced. Correlation and causation. The correlation between two variables measures the strength of the relationship between them, but it does not indicate the cause and effect relationship between the variables. Correlation means covariation, not causation. Causation means change in one variable affects or causes the change in the other variables. Or in other words, just because of two events or things occur together does not imply that one is the cause of the other. What are the different types of correlation? Correlation may be positive and negative correlation, and the second one is linear and non-linear correlation. If two variables changes in the same direction, That is, if one increases, the other also increases, or one decreases, the other also decreases. Then this is called a positive correlation. For example, advertising and sales. Some other examples of series of positive correlations are height and weight, household income and expenditure, price and supply of commodities, amount of rainfall, and yield of crops. These are normally the examples of positive correlation. If two variables changes in opposite direction, that is, if one increases, the other decreases, and vice versa, then the correlation is negative correlation. And the examples are TV registrations and TV cinema attendance. Some other examples, what we can see in our practical life, or day life, that is volume and pressure of perfect gas is inversely proportional. Current and resistance keeping the voltage constant, that is the Ohm's law. Price and demand for goods, that is the case for economics. Linear and non-linear correlation. The nature of the graph gives us the idea of linear type of correlation between two variables. If it is a straight line in any direction, it is a linear correlation. And if the points are joined and a linear line is not formed, or a curve is formed, then that is a nonlinear correlation. If the graph is a straight line, the correlation is called linear correlation. And if the graph is not a straight line, it is a correlation of nonlinear or curvilinear type. In general, two variables x and y are said to be linearly related if there exists a relationship of the form y is equal to a plus bx. This is somewhat similar to the equation of a line. Now, I will be converting, or I will be using this with the equation of line, where a and b are real numbers, and this is nothing but a straight line when plotted on the graph sheet with different values of x and y, and for constant value of a and b. Degree of correlation. Through the coefficient of correlation, we can measure the degree of or extent of the correlation between the two variables. On the basis of coefficient of correlation, we can also determine whether the correlation is positive or negative, and also its degree or extent. Perfect correlation. If two variables change in the same direction and in the same proportion, the correlation between two is perfect positive. According to Carl Pearson, the coefficient of correlation in this case will be +1. On the other hand, if the variable changes in the opposite direction and with the same proportion, the correlation is perfect negative. And in that case, coefficient of correlation will be -1. Absence of correlation. If the two series of variables exhibit no relation between them, or change in one variable does not change in the other variable, then we can firmly say that there is no correlation or absent correlation between the two variables. In such case, R, the coefficient of correlation will be 0. That means what we find, that the correlation may be positive, negative, or 0, but the limit lies between +-1. That means the value of R will depend between -1 and 1. The plus sign and negative signs are used for positive linear correlation and negative linear correlations respectively. Now you should remember this, because this conclusion is sometimes asked after at the end of the what you have found. Absence of correlation means R is 0. Perfect correlation means +1 for positive, -1 for negative. And if the degree is between 0.75 to +1, and here minus 0.75 to -1, where we can say that there is high degree of positive or negative correlation. Moderate one, 0.25 to 0.75. And from low degree, it is 0 to 0.25. R is a dimensionless quantity, and this does not depend on the units employed. Because during calculation, units get cancelled off. The properties of correlation coefficient. Listen to it very carefully. Normally, learners do mistake in solving the numerical, because at that time solving the numerical you have to take a call. Now listen to it. The correlation coefficient R lies between -1 and +1. The correlation coefficient R is a pure number and is independent of the units of measurement of the variables. The correlation coefficient R is independent of change of origin. That is, the value of R is not affected if each of the individual value of the two variables is increased or decreased by some non-zero constant. Correlation coefficient R is independent of change of scale. That is, the value of R is not affected even if each of the individual values of two variables is multiplied or divided by some non-zero constant. Now, what are the methods of determining correlation? First of all, the first method is scatter plot. Second one is Karl Pearson coefficient of correlation. And the third one is Spearman's rank correlation coefficient. These are all numerical based problems. A scatter plot is used to graphically investigate the possible relationship between the two variables without calculating any numerical value. In this method, the value of the two variables are plotted on a graph paper. Read this. Now, these are all the possible correlation graphs. If you remove the line from this diagram, this diagram, and this diagram, remove this line. The dots are the scatter diagram. Dots are the scatter diagram in all the four. Now, depending upon the value of R, when a line graph is plotted, in the first diagram, R is increasing. In that case, that is a perfect positive correlation. That means R is equal to +1. High degree of positive correlation, again of that the thickness of this graph. I'm talking about this part. This thickness is small. There is low degree of positive correlation. It's increasing, moving in this, but these diagrams, these dots are scattered much far. This is coming down. That means this is a perfect negative correlation. R is equal to -1. High degree because this width is less, and low degree because this thickness is more. So this is the graphical representation. All points are scattered everywhere. R is equal to 0. No correlation is there. Now comes your Karl Pearson coefficient of correlation. It gives the precise numerical expression for the measure of correlation. It is denoted by R. The value of R gives the magnitude of correlation, and its sign decides its direction. The mathematical formula for computing R is equal to sigma xy upon n times of sigma x and sigma y. This x minus x bar is from the mean. Y minus, that means in this problem, first of all, you have to calculate mean and then standard deviation. The standard deviation formulas are written over there. Sigma x is equal to under root sigma x square by n, and similarly for the y. And when you are joining these together, replacing sigma x and sigma y in this formula, you will get this relation. That means you have to remember this as well as this. Now, depending upon the numerical values given in the problem, the formula has to be modified to make it simpler, to make calculations simple. You can see there are three. Basically, there are four formulas. You have seen this formula, and now this one is from the deviations. R is equal to sigma x minus x bar into y minus y bar upon under root x minus x bar. So don't remove this square by under root. Now, if you are taking assume mean method, so this second formula is used. And if you are taking direct method, the third one is used. If covariance is given in the problem, then this formula has to be used. These formulas are basically depending upon the conditions given in the numerical problem. Now comes Spearman's rank correlation coefficient. It is denoted by capital R. This method is based on ranks of the items rather than on the actual values. The advantage of this method over the other is that it can be used even when the actual values of items are unknown. For example, if you want to know the correlation between honesty and wisdom of the boys of your class, you can use this method by giving ranks to the boys. It can also be used to find out the degree of agreements between judgments of the two examiners or two judges. The formula is R is equal to 1 minus 6 sigma d square upon n into n square minus 1. Now, again this R, value of R will be between minus 1 and 1. Same conditions apply. If R is plus 1, it is positive, perfect positive correlation. R is minus 1, it is perfect negative correlation. And if R is equal to 0, there is no correlation. Now, computation of how this computed. Formula is 1 minus 6 sigma d square upon n into n square minus 1. Now, how to calculate d? Given ranks to the value of the item, generally the item with the highest value is ranked 1, and then the others are given 2, 3, 4, 5, 6, and so on in that decreasing order. Find the difference between the two ranks, that is R1 and 2, because you will be comparing two things. So R1 and R2, find out the D. Then you have to square it. Then you have to add. That means value will come out to be sigma D square. And then you have to apply the formula. Now this is the problem. From the following information, find the correlation coefficient between advertisement expenses and sales volume using Carl Pearson coefficient of correlation method. Now you can see that there are two terms, advertisement in lakhs and sales volume in lakhs. You have to find out, first of all, the correlation coefficient. That means we are talking about R. The small r. Convert this table into a vertical table. X, capital X and capital Y is given to you. Since we have to find standard deviation, so we have to calculate x minus x bar and y minus y bar. Y bar means mean, mean of y and mean of x. Mean of x is summation of x upon n. See, summation of x is 140, summation of y is 580. You have 10 observations, that means x bar will be 14 and y bar will be 15. Simply subtract, start subtracting all these values. You will get this. Square it, you will get this. Y small y is equal to y minus y bar. Y bar is 58. Subtract, start subtracting and do the square. You will get this value and square it. Then you have to calculate x into this x into this y. Again add up. That means this value is required, this value is required, now this value is required. Place of the values. R is equal to sigma xy upon under root sigma x square into under root sigma y square. X square value is which one? X square value is this one. And y square value is this one. And xy value is this one. After calculation, we will get 0.786. What is the interpretation? 9 is positive and it is more than 75. That means from the above calculation, it's very clear that there is a high degree of positive correlation of R is equal to 0.786 between the two variables. That is, increase in advertisement sales leads to increased sales volume. Understood है? Logically हम ये सुनते हैं जितना पैसा आप खर्चे, as much as you increase the expenditure in advertisement, your sales will increase. Now comes regression. Regression analysis is a statistical method that helps us to analyze and understand the relationship between two or more variables of interest. The process that is adapted to perform regression analysis helps to understand which factors are important and which factors can be ignored and how they are influencing each other. For example, we can say that age and height can be described using a linear regression model. Since a person's height increases as his age increases, they have a linear relationship. Now we will see how this relationship is generated. Regression models are commonly used as a statistical proof of claims regarding everyday fact. A researcher might administer various dosages of a certain drug to patients and observe how their blood pressure responds. This can be broadly classified into two major types. First one is linear regression, and the second one is logistic regression. Now, what is the difference between correlation and regression? As far as correlation is concerned, it measures the degree and direction of relationship between the two variables. It is a relative measure showing association of the two variables. Correlation coefficient is independent of change of both origin and scale. Correlation coefficient is independent of unit of measurement, and its value lie between -1 and +1, and it is not a forecasting device. But regression, on the other hand, very tedious calculations are to be done, and it measures the nature and extent of average relationship between two or more variables in the form of original unit of the data. It is an absolute measure of relationship. Regression coefficient is independent of change of origin but not scale. Regression coefficient is not independent of unit of measurements because your answer will come in that unit only. Expression of relationship between the two variables in any of these two forms, you have to convert this y is equal to a plus bx or y is equal to a plus bx plus cx squared. It is a forecasting device which can be used to predict the value of the dependent variable from the given value of independent variable. Now, regression lines and regression equations. Regression lines and regression equations are used synonymously. Regression equations are algebraic expressions of the regression line. Let us consider two variables x and y. If y depends on x, then the result comes out in the form of simple regression. We know the equation y is equal to a plus bx. If we take the case of two variables x and y, we shall have two regression equations as a regression line of x on y and regression line of y on x. The regression line y on x gives the most probable value of y for a given value of x, and the regression line of x on y gives the most probable value of x for a given value of y. That is why we have two regression lines. However, when there is an either perfect positive or perfect negative correlation between the two variables, the two regression lines will coincide and we will have one line. If the variables are independent, R is 0. And then the lines of regressions are at right angles, that is parallel to x-axis and y-axis. Now, this is what you have to remember. Regression line of y on x. This line gives the probable value of y for any given value of x. The regression line on, see the difference, what is the difference between these two? Regression line of y on x. Y minus y bar is equal to byx into x minus x bar. Or mathematically, after solving it, you will get y is equal to a plus bx. And on the other hand, regression line of x on y. This line gives the probable value of x for any given value of y. So here x minus x bar is equal to bxy into y minus y bar. And this equation will be converted as x is equal to a plus by. If the two regression lines or regression equations, there are two regression parameters which are a and b. If a is known, if a is unknown and b is also denoted by byx or bxy, is also another unknown constant, probably known as regression coefficient bxy and byx. Hence, these a and b are two unknown constants. They are fixed numbers which determine the position of the line completely. Here it comes how this will be found. The parameter A determines the level of the fitted line, that is the distance of the line directly above or below the origin. The parameter B determines the slope of the line, that means it is moving up or it is coming down. If the values of constant A and B are to be obtained, the line is completely determined. But the question is how to obtain these values. The answer is provided by the method of least square. This is in terms for x on y. Summation x is equal to n into a plus b summation y. And the second equation is, because there are two variables, so you need two equations to solve them. Second equation is summation xy is equal to a summation y plus b summation y square. Similarly, y on x. Summation y is equal to na plus b summation x. And some second equation, summation xy is equal to a summation x plus b summation x square. See the difference in the two. This method is popularly known as direct method, which becomes quite cumbersome when the values of x and y are large. This work can be simplified if instead of dealing with different values of x and y, we take a deviation of x and y series from a respective mean. That means you will be using now mean. The regression line of y on x, y is equal to a plus bx, can be changed as y minus y bar is equal to byx into x minus x. And similarly for y is equal to, so that equation will change as x minus x bar is equal to bxy into y minus y bar. In this new form of regression equations, we need to compute only the parameter b. This b, which is to be denoted by bxy or byx, which is called as regression coefficient. The quantity b in the regression equation is called the regression coefficient or slope coefficient. Since there are two regression equations, so there will be two regression coefficients, bxy and byx. Now how to calculate their values? For calculation, direct calculation of bxy is equal to r times of sigma x upon sigma y. When the equation is in the form of x on y, your direct method is bxy is equal to this formula. And when deviations are taken, then bxy will be equal to sigma xy upon sigma y square, where small x is equal to x minus x bar and small y is equal to y minus y bar. Similarly for x on y. Now see the properties. The coefficient correlation is the geometric mean of two regression coefficients. Symbolically, r is equal to under root bxy into byx. If one of the coefficient is greater than unity, then the other one will be less than unity. Since the value of coefficient of correlation cannot exceed unity. Okay. Number 3, both the regression coefficients will have the same sign. That is when they will be either positive or negative. In other words, it's not possible that one of the regression coefficients is with minus sign and the other one is with the plus sign. These three things have to be kept in mind. Well, this will be useful for solving the numerical. And the fourth one is the coefficient of correlation will have the same sign as that of the regression coefficient. If bxy and byx have the minus sign, your r will be minus. And if both x and y, bxy and byx are positive, r will be positive. Now we will calculate. After investigation, it has been found that the demand for automobiles in a city depends mainly, if not entirely, upon the number of families residing in that city. Below are the given figures for sales of automobiles in 5 cities of the year 2019, and the number of families residing in these cities are Belagavi, Bangalore, Hubli, Kalaburga, and Mangalore. Number of families and number of automobiles. So first we will take X and the other we will take Y. Fit a regression line equation Y on X by the least square method and estimate the sales for the year 2020 for the city Belagavi, which is estimated to have 100 lakhs family, assuming that the same relation holds true. आपका जो regression है, that is a forecasting technique. That is why the data is given for 2019 and we are estimating for 2020. How to estimate it? These first three columns were given to you. Now what you have calculated? X square and xy. Now the question arises why? Because we have to find y is equal to a plus bx. And we have to use least square method. That means least square method is summation y is equal to an a plus b summation x, and summation xy is equal to a summation x plus b summation x square. This is what we have calculated. Substitute these values in these two equations. Now by the method of elimination, either eliminate a or b. After solving it, you will get a is equal to minus 4.885 and b as 0.443. Your equation will be y is equal to minus 4.885 plus 0.443x. Now what was asked? You have to estimate the value of Belagavi city for 2020 for whether the number of families are 100. Just put up the value of 100 in terms of in place of x. So you will get the value for Belagavi for 2020, and that comes out to be 39.415. Earlier it was 25, now it will become 39.4. Now comes your time series analysis. A time series is a sequence of data points measured typically at successive times, spaced at uniform time interval. The time interval may be an hour, a day, a week, a month, or a year, depending upon the purpose of data collection. Most commonly, a time series is a sequence taken at successive, equally spaced points in a time. Thus, it is a sequence of discrete time data. Examples of time series can be used in pattern recognition, signal processing, weather forecasting, and earthquake prediction. Time series analysis comprises methods of analysis time series data in order to extract meaningful statistics and other characteristics of the data. It is used to detect patterns of changes in statistical information over regular intervals of time. These patterns helps us in arriving at an estimate for the future so as to cope up with the uncertainty about the future. Time series forecasting is the use of model to forecast future events based on known past events. That is to predict data points before they are measured. An example of time series forecasting is econometric is predicting the opening price of the stock based on its past performance. And forecasting is an essential tool in strategic planning and decision-making process of an organization. Application of time series. Various applications of time series are economic forecasting, sales forecasting, budgetary analysis, stock market analysis, yield predictions, process and quality control, inventory studies, workload projections, utility studies, and Celsius analysis. The usage of time series model is twofold. First is to obtain an understanding of the underlying forces and structure that procedure, produce the observed data, and second is to fit a model and proceed to forecasting, monitoring and feedback, and feed forward control. Variations in the time series. Now there are four types of variation. These four types of variations are secular trend or long-term trend, cyclic fluctuations, seasonal variations, and irregular variations. Secular trend or long-term trend. Here the value of variable tends to increase or decrease over a long period of time. The variable may be proportional, sales, cost of living, death rates, and so on. The trend includes steady movement over a fairly long time and does not include short-time oscillations. The trend may be in the form of slow or fast increase or decrease. These changes occur as a result of general tendency of the data to increase or decrease as a result of some identifiable influences. This trend is commonly seen in data related to economics, business, and population. Cyclic fluctuation. The cyclic fluctuation refers to regular swings or pattern that repeats over a period of time. Cycles are the upward and downward movement about the trend line over a period of time. The movements are considered cyclic if the fluctuation occurs after the time interval of more than 1 year, or it can be as many as 20 years. In general, these cycles are not regular. They may not they may have different periods and intensity, that is the amplitude. The most common example of cyclic fluctuation is business cycle. The cycle variations are affected by erratic, irregular, and random forces, which cannot be separated to measure their impact accurately. Seasonal variation. Seasonal variation involves patterns of change within a year that tends to be repeated after year to year. For example, sales of ice cream increases in summer. As these variations are regular patterns, they can be predicted fairly accurately. Some factors that causes seasonal variations are season and climate. Change in climate and weather affect the sales of many products. For example, sales of coolers, ACs is always more during summer months. Customer and customs and festivals. Tradition and customs also affect the pattern of the sales. For example, sales of paints and furnishing goods is more during Diwali. Sales of sweets is more during festivals. Irregular variations. Irregular variations are rapid, unpredictable, and random changes in the data. The changes are caused by short-term, unanticipated, and non-recurring factors. Incidents like wars, strikes, floods, famine, earthquake, etc. The effect of Iraq war and terrorist attack on crude oil prices is an example of irregular variation. Decomposition of time series. Analysis of time series consists of identification of various factors which causes the variation in the time series and separating, analyzing, and measuring the effect of those sales factors independently. The objective of composition of time series is to break time series into four components, that is trend, cyclic, seasonal, irregular, so as to isolate influence of each of the four components of the actual series. So that means we have two models. But the first one is multiplicative model and the second one is additive moment. So firstly we will be multiplying both the four factors. That is y is equal to t into c into s into I. And in the additive we will be adding 4. This model is less common. It is appropriate in situations where variables in the time series are in absolute value and can be separated to each other by 4 parts. Here each part is independent. Each part has a negative or positive value. What are the measurements of secular trend? Secular trends measures the long-term direction of series. The study of secular trends helps in identification of a historical pattern, projecting past patterns into future, and eliminating the trend components from the series. The most important method for measuring secular trend are freehand curve, sum average methods, moving average method, and method of least square. Freehand curve, you have to draw a freehand by joining the different points on the pattern. It is the simplest method. It consists of plotting the time series value on a graph paper and then drawing a freehand smooth curve through these points so as to reflect the long-term tendency of the data. This method is based on inspection, hence is subjective in nature. That is, it is only a specialist with long experience who knows the behavior of the variables can draw a line by inspection. Semi-average method. In semi-average method, the data is divided into two equal parts and arithmetic means are calculated for each of the part. These are called semi-averages. These 2 points are plotted considering to the midpoint of the respective class intervals covered by each part. The lines joining the 2 points give the straight line trend lines. These lines can be extended upwards and downwards to get an estimated future and past values. Advantage is it is not based on personal judgment. Hence, same trend can be obtained every time. Easy to understand. Trend lines can be extended upward or downwards to estimate future and past values. Disadvantage, it is based on assumption of linear trend. We assume that we will be getting a straight line. Use of arithmetic mean. Arithmetic mean has its own limitations and it may not be appropriate method in some cases. Moving average method. The moving average method is based on the concept that if the observations at a point in time are averaged out with the values immediately before and after it, it will smooth out the irregular components of the time series. This is very common method to determine secular trends. This trend is subjective as it depends on selection of the length of the period for calculating moving average, for example, 3 years, 4 years, or 5 years, so as to remove the effect of cyclic variations. Least square method, again, equation of a line. This method is based. This is the method in which a trend line is determined using a mathematical equation of either a straight line or a parabolic curve. As this method is based on mathematical equation, it is not subjective and hence it is more accurate. The equation used for fitting a straight line, that is yc is equal to a plus bx, where yc is the predicted value of the dependent variable x, is the independent variable, which is this case is time. Further, a is the intercept and b is the slope. Both a and b are constants. The trend lines have the following properties. The summation of all vertical deviations from it is 0. That means summation y minus yc is equal to 0. And the sum of the variations, vertical deviations squared is minimum. That means summation of y minus yc squared. तो आप इसको करेंगे that will be least. Fitting a straight line, The equation line used for fitting a straight line is yc is equal to a plus bx, where yc is the predicted value, a is the intercept, b is the slope, and x is the independent variable, that is the time. Now for solving a and b, again these two equations will be used. The independent variable x is given order number 1, 2, 3, 4, 5 for calculating summation x. Auto regression integrated moving average ARMA model predicts future values based on past values. ARIMA makes use of lagged moving average to smooth time series data. They are widely used in technical analysis to forecast future security prices. An outline of Box-Jackinson model for the time series. Box and Jackinson in 1976 had proposed a sophisticated methodology for statistic modeling models, building and forecasting using time series. The time series may be classified as stationary, that is in equilibrium about a constant mean value, or non-stationary when the process has no natural or stable mean. In schematic model, building the non-stationary processes often converted to a stationary one by differencing. The two major classes of model used properly in time series analysis are auto-regression and moving average models. Auto-regression model. In such models, the current value of the process is expressed as a finite linear aggregate of previous value of the process and a random shock or error, that is alpha t. Let us denote the value of process are equally spaced, that is t, t minus 1, t minus 2, and zt. Zt minus 1, zt till infinity. So your zt will be, mean zt will be zt minus m. Then you have to calculate zt is equal to phi 1 zt minus 1 till the last part will be 80. This is auto-regression process of order P. This represents a regression of variable z t on successive values of itself. The model contains p plus 2 unknown parameters, that is phi 1 2, pi p, and sigma square n, which in practice have to be estimated from the data. The additional parameter sigma square is the variance of the random error component. Now we talk about moving average models. Another kind of model of great importance is the moving average model, where Z is made linearly dependent on a finite number Q of previous A's. That means Z is equal to AT minus theta 1, AT minus 1 plus theta 2, AT minus 2 till theta Q AT minus P. This is called moving average process of order Q. This model contains Q plus two unknown parameters, M, theta 1, theta 2, theta Q, and sigma square A, which in practice have to be estimated from the data. For non-stationary process, the most general model used is auto-regressive integrated moving average, ARIMA, process of order PDQ, where D represents the degree of differencing to achieve stationality in the process. The main contribution of Box and Jacobson is the development of procedures for identifying the ARIMA model that best suits or best fits a set of data. and for forecast and for testing and adequacy of that model. The various stages identified by Box and Jackinson in their interactive approach to model building are shown here. Here you will see the methodology which was followed in Box Jackinson methodology. I don't know how many of you are holding pen and pencil with you, but now you have to keep pen and pencil with you. Whatever we have heard in 2 days, and now the numerical component will be asked. I will be showing you some of the problems which are related to your subject. Now you have to identify which type of formula has to be applied. Now see, the average monthly sales of 5,000 firms are normally distributed with mean of 36,000 and standard deviation of 10,000. Find the number of firms with sales of over 40,000. Can any one of you tell me this problem is related to which part of the subject? You have three parts in it. The second part is the percentage of the firm with sales between 38,500 and 41,000. And the third one is the number of the firms with sales between 30,000 and 40,000. The solution is in front of you. I'm just asking about your opinion about going through the problem. It is related to which part?
Sir, normal distribution.
नॉर्मल डिस्ट्रीब्यूशन में आपको क्या क्या चाहिए होता है?
सर फॉर जेड स्कोर वाले पार्ट में x माइनस म्यू बाय स्टैंडर्ड डेविएशन.
आपको क्वेश्चन में गिवन है जेड का फॉर्मूला क्या है, ये तो बताइए पहले.
x माइनस म्यू बाय स्टैंडर्ड डेविएशन.
आपको गिवन है वो प्रॉब्लम में एक्स गिवन है, तो एक्स बताइए एक्स कितना है. व्हाट इज द वैल्यू ऑफ एक्स?
सर 36,000.
भैया 36,000 कहां से आ गया?
दैट इज मीन
एक्स पूछ रहा
36,000.
हूँ, एक्स पूछ रहा हूँ, एक्स
40,000.
क्यों 40,000 क्यों? अरे वही तो क्वेश्चन है आपका. नंबर ऑफ फर्म्स विद द सेल्स ऑफ ओवर 40,000, वो आपका एक्स है. न्यू कितना है? 36,000. एसडी कितना है? 10,000.
10,000.
सबसे पहले आप क्या निकालेंगे? जेड. जेड की वैल्यू कितनी आएगी? 0.4. ठीक है, आपको प्रोबेबिलिटी निकालनी है z ग्रेटर देन 0.4. इसका मतलब इसकी वैल्यू को आप 0.4 की वैल्यू को जो आपको प्रॉब्लम में गिवन होगी उस 0.4 की वैल्यू को 0.5 से सब्ट्रैक्ट कर दीजिए. दैट विल कम आउट टू बी 0.3446. अब आपका सैंपल साइज कितना है? 40,000. 40,000 से इसको मल्टीप्लाई कर दीजिए. you will get 1723. That means
Five
number of
thousand.
firms with sales of
5,000 से मल्टीप्लाई किए.
आपका वो कितना है?
सैंपल साइज 5,000.
हाँ 5,000 से ही होगा. So that comes out to be 1723. अब आपको सेकंड पार्ट के अंदर z निकालना पड़ेगा 2 बार और थर्ड पार्ट के अंदर भी z निकालना पड़ेगा 2 बार. ये रहा सेकंड पार्ट. थर्ड पार्ट के अंदर भी आपको z निकालना पड़ेगा 2 बार.
ओके सर.
और z की वैल्यू आपको प्रॉब्लम के अंदर क्वेश्चन के अंदर गिवन होगी. अब ये आ गया मैथमेटिकल रिलेशन उसका नॉर्मल डिस्ट्रीब्यूशन का वन आपको z की वैल्यू दी हुई होगी. यानी कि योर क्वेश्चन विल बी डायरेक्टली इन टर्म्स ऑफ z. फर्स्ट ऑफ ऑल में क्या आया p 0 लेस देन ग्रेटर देन लेस देन इक्वल टू z लेस देन इक्वल टू 1.3. 1.3 पॉजिटिव साइड में आपको इसका एरिया निकालना है. क्रेडिट पार्ट का एरिया कितना होगा? जितना z की वैल्यू है दैट इज 1.3. उसका आंसर आपका आएगा 0.4032. सेकेंड पार्ट में नेगेटिव साइन आ गया तो लेफ्ट साइड में चला जाएगा. थर्ड में क्या आया? बिटवीन -1 एंड 2. -1 लेफ्ट साइड में होगा, 2 राइट साइड में होगा. दोनों को ऐड कर दो. z at 1 and z at 1 and z at 2 आपको वैल्यूज पेपर में गिवन होंगी. ये कहाँ आया? z इज ग्रेटर देन 1.54. 1.4 से ग्रेटर देन हो गया तो राइट साइड में चला गया. 0.5 से सब्ट्रैक्ट करिए क्योंकि पूरे की प्रोबेबिलिटी 0.5 होती है. उसमें से z की वैल्यू को सब्ट्रैक्ट कर लीजिए तो आपको शेडेड रीजन का एरिया आ जाएगा. अब नीचे वाले में क्या हुआ जरा गौर से देखिए. मॉड वैल्यू है p mod of z greater than 2. दैट मीन्स मॉड वैल्यू है तो z की 2 वैल्यू होंगी +-2. फर्स्ट केस में आ गया p z इज ग्रेटर देन 2 और दूसरे केस में आ गया p इज लेस देन -2. दोनों सिमेट्रिकल हैं क्योंकि एक तरफ +2 है एक तरफ -2 है. दोनों सिमेट्रिकल है. p z इज इक्वल टू 2 पे वैल्यू निकालिए और 2 से मल्टीप्लाई कर दीजिए. आपको बीच का एरिया चाहिए, वह बाहर का एरिया आपको 1 में से सब्ट्रैक्ट करना पड़ेगा क्योंकि कंप्लीट प्रोबेबिलिटी इज 1. लेस देन 2. अब बीच का चाहिए तो 1 से सब्ट्रैक्ट नहीं होगा. But these are the different combinations of solving a problem. This is what? Now, see. 2 different types of drug A and B are tried on certain patients for increasing weight. 5 persons were given drug A and 7 persons were given drug B. The increase in weight in LBS is given here. Do the 2 drugs differ significantly with regards to their effect in increasing weight? Tabulated value at 0.05 by 2 at 10 degrees of freedom is 2.23. अब आप मुझे ये बता दीजिए what will you do? और आपने सारी कैलकुलेशन आज ही पढ़ी है, अभी 1 घंटे पहले. Just let me know what will be done. The problem is in front of you. नहीं मालूम. चलिए अब देख लीजिए. दो डेटा है, ड्रग ए और ड्रग बी. ड्रग ए के अंदर कितने हैं? 5. और ड्रग बी में कितने हैं? 7. आपने एक्स बार निकाल लिया, एक्स 1 बार एंड एक्स 2 बार, और आपने डेविएशन निकाल लिया और उनका सम कर दिया. ये आपने क्या निकाला अभी? S इज इक्वल टू एस टेस्ट पर सैंपल. एस निकालना पड़ेगा सबसे पहले. नल हाइपोथेसिस इज H नॉट इज टू μ1 इज इक्वल टू μ2. ऑल्टरनेट में क्या होगा? दे आर नॉट इक्वल. तो टी टेस्ट करने के लिए मुझे x1 बार माइनस x2 बार अपॉन ये फॉर्मूला यूज करना पड़ेगा. और मेरे पास डिग्री ऑफ फ्रीडम कितने हैं टर्म्स? N1 में कितने थे? 5 और दूसरे में 7, 6. 4 + 6 इज 10. बट 10 डिग्री ऑफ फ्रीडम, आपको पेपर में 10 डिग्री ऑफ फ्रीडम गिवन था. 10 degree of freedom is given.
Yes.
Value is 2.23. That is what I'm telling you. And your calculated value is negative 0.501. Okay, now what happens? Your calculated value is negative 0.501 and your tabular value is 2.23. Will you accept the hypothesis or you will reject the hypothesis? आपकी कैलकुलेटेड वैल्यू है नेगेटिव 0.501 और आपकी टेबुलर वैल्यू है 2.23. विल यू एक्सेप्ट इट और विल यू रिजेक्ट द नल हाइपोथेसिस?
Accept it.
कैलकुलेटेड वैल्यू अगर कम है तो आप हमेशा एक्सेप्ट करेंगे. नो, दिस इज अ प्रॉब्लम रिलेटेड टू व्हाट? Assume the mean height of soldiers to be 68.22 inches with the variance. Now here, see the thing, here variance is given 10.8. How many soldiers in the regiment of 1000 could you expect to be over 6 feet tall? And the tabular value of area between 0 and 1.15 is 0.3749. That is clear that you have to calculate Z. And for calculating Z, you want standard deviation, and question shows you variance. So by getting it, take it under square root. Your x is 6 feet. Now see the problem. The data in the question is given in inches and the answer has been asked in feet. So first of all, you have to convert this 6 feet into inches. Normally what you will do? You will simply write 6 minus 68.22 upon under root 10.8. तो आपका आंसर आएगा माइनस में और वो that is totally wrong. 6 feet, above 6 feet. That means on the right side. And the answer will be subtracted from 0.5. And the value of that area is 0.3749. Okay. So what is the probability of the shaded region? That is 0.1251. That means approximately 12.5% of soldiers will be above 72 inches. And the required probability will be on the numerical number in terms of, because regiment is of 1,000. So that means you have to multiply this probability by 1,000, which comes out to be approximately 125 soldiers. So this is the complete answer. Now, the average time of customers' arrival per minute at a super bazaar is 2. Find the probability that during one particular minute, exactly 3 customers will arrive. Second one, at the most 2 customers will arrive. And the third one, at least 1 customer will arrive. Now, straight away, you can see over here that this is a problem which is related to which probability part? Arrival per minute is given. That means we can, if you remember, we had a formula in terms of lambda and m.
Poison.
So here it is m is equal to 2. And your random variable is r. So if, what are the 3 values of r will be x, for the first r will be equal to 3, and for second r will be less than 2, and the third one it will be 1 minus 1, at least 1 customer. The 1 minus probability of r is equal to 0. The value of e minus e raised to the power minus 2 will be given to you in the paper. You have to simply remember which part of the probability has to be applied, under how this can be solved. This was done by you people yesterday. Suppose we know that the weight of cement in filled bags is distributed normally with a standard deviation of 0.2 kg. We want to know how large a sample should be taken so that the mean weight of the cement in a filled bag has to be estimated within plus or minus 0.05 kg of its true value. And you have to consider a confidence level of 90%. For 90%, that was x bar plus minus 1.65 into sigma upon under root n. What for that? What you have to calculate? You have to calculate n. N has to be calculated as everything has been given to you. So here n will be 43.3, which we can make either 43 or we can make 44. Because the question asks you the number of bags. We have to see whatever is given in the problem and what has to be found. Another application of probability. Insurance salesman sells policies of to 5 men, all of identical age and good health. According to the actual tables, the probability that a man of his particular age will be alive 30 years hence is 2 by 3. What is the probability that 30 years hence at least one man will be alive? And second one is at least 3 men will be alive. What is P? This is a problem of probability. Your N is 5, probability is 2 by 3, Q will be 1 by 3. And you have to apply PR is equal to NCR, P raised to the power R, Q raised to the power N minus R. In first case, at least one is alive. So that means you can calculate 1 minus PR is equal to 0. And for at least 3 is included means, so you have to calculate P3, P4, P5. Remember one thing, probability, answer of the probability cannot be greater than 1. Now, in a normal distribution, 35% of the items are under 45 and 8% are above 64. Calculate the mean and standard deviation. Here the probability in percentage is given. So that means 31% means 0.31 and 8% means 0.08. What you have to calculate? Mu and standard deviation. For calculating mu and standard deviation, there are 2 unknowns. That means, first of all, one thing should click into your mind that 2 equations have to be formed. And this is a normal distribution question. Your probability has been given to you. The first case is the x less than 45. See how it is being solved. Here in the table, what you are going to get from the table? You have to refer to the table where the value of 0.19 lies. Value of 0.19 will lie for z is equal to 0.49. So you have to convert this equation into 2 unknowns. That is mu minus 0.49 sigma is equal to 45. This is from the first equation. That means 31% of the items are under 45. Now for second, what will we be doing? X is greater than 64. Convert this. From the table, you will get value of 0.42. Convert this. The second equation will be mu plus 1.4 sigma is equal to 64. 2 equations, 2 unknown. Solve them and by elimination method, and you will find that mu is equal to 50 and sigma equal to 10. Now comes your Bayes theorem. A car manufacturing factory has 2 plants X and Y. Plant X manufactures 70% of cars and plant Y manufactures 30%. 80% of the cars at plant X and 90% of the cars at plant Y are rated of standard quality. A car is chosen at random and is found to be of the standard quality. what is the probability that it is came from the plant X? If I remember, I have done this problem yesterday also. This is Bayes' theorem is a case of conditional probability. Two plants are there, but the condition is getting a quality car from plant 1. Yesterday, somebody told me the answer of the second part. This is B1E. I asked B2E. Now see sampling distribution. The average monthly electricity consumption for a sample of 100 families is 1250 units. Assuming the standard deviation of electric consumption of all families is 150, construct a 95% confidence interval estimate of the actual mean electric consumption. Okay. Mean is given to you, sigma is given to you, n is given to you, and the confidence level is 95%. That is also given to you. What you are supposed to ask, what you have to calculate. Using the standard normal curve, we can find the half of 0.95 yields a confidence coefficient set alpha by 2 equal to 1.96 for standard. 95% पे 1.96 होता है. Here it comes. Confidence limit will be alpha by 2 plus minus 1.96 for 95% of confidence, and is given by x bar minus z alpha by 2 times sigma upon under root n. The other side it will be plus. You will pick up the value and you will get 12.50 plus minus 1.96 into 150 divided by 100, which comes out to be 1279.40 and 1220.60. That means its value will be between this. Testing of hypothesis. A typist claims that he can type at a rate of 120 words per minute. Can we reject his claim on the basis of 100 trials in which he demonstrates a mean of 116 words with a standard deviation of 15 words, and you have to use 5% level of significance? Your hypothesis that his claim is H naught is to mu is equal to 120. An alternate hypothesis is that it is not equal to 120. It is a case of two-tailed test. You have n is equal to 100, x bar is equal to 116, mu is equal to 120, and s is 50. Now the question arises, we have to calculate standard mean error. That is sigma upon under root n, which is 1.5. Why we have used this formula? Because where is the standard deviation? And there is a sample size of 15. So this comes out to be z is equal to 2.67. Level of significance is 0.05. And for this value, your tabular value says 1.96. Your calculated value is 2.67. Will you accept it or will you reject it? Your calculated value is greater than tabular value. What will you do?
Reject it.
Another case of hypothesis testing. A mean lifetime of a sample of 100 bulbs, 400 bulbs produced by a company is found to be 1570 hours with standard deviation of 150 hours. Test the hypothesis that the mean lifetime of the bulb produced by the company is 1600 hours against the alternative hypothesis that it is greater than 1600 hours at 1% level of significance. What is given to you? N is equal to 400, that is too large. X bar is 1570 given. ST 150 hours given. Mu is equal to 1600 hours again given. Correct? Original hypothesis, that means your null hypothesis is H naught is to mu is equal to 600. And alternate hypothesis is that it is greater than 1600. So H1 is to mu greater than 1600. It is a case of right tilt test. कि एक side में increase करेगा वो. What will you? How will you proceed? Standard error निकालिए. 150 upon under 400. This comes out to be 7.5. Z score निकालिए. X bar equal to mu upon S divided by under root n. This comes out to be -4. Your calculated value is 2.33. Your calculated value is -4 and your tabular value is 2.33. What will you do? You will accept it or reject it?
Accept it.
यार आंसर पढ़ लीजिए, आंसर क्या लिखा हुआ है और क्यों लिखा हुआ है. आप
A correction is a reject. Oh, this is higher than the tabular value.
नाउ हम आपको दो पॉपुलेशन दिखाएंगे. पॉपुलेशन प्रोपोर्शन चाहिए. In a sample of 1000 people in Mumbai, 540 are rice eaters and rest are wheat eaters. Can we assume both rice and wheat are equally popular in this state at 1% level of significance? What is given to you? Only three numbers are given. N is 1000, X is 540, and the state of 1% level of significance. That's nothing is given to you. And you have been asked to calculate. Can we assume that both rice and wheat are equally popular in this state? What will you do? You have to generate P because you don't have X, you don't have mu, and you don't have sigma. So here what we equally likely means the probability of both P and Q will be half, 1 by 2 and 1 by 2. H naught में आपको H naught is to P is equal to 0.5 and H1P, alternate hypothesis will be H1P which is not equal to 0.5. Now small p is 0.54, N is 1000, capital P is 0.5, capital Q is 0.5. The formula for Z is P minus P upon under root PQ by N. Place above the values, you will get the answer of 2.529. Your calculated value is this and your tabular value is 5.28, 2.58. What will you do? Calculated value बड़ी है या tabular value बड़ी है? Which one is bigger?
Calculated value is bigger.
So calculated value is bigger. How it is bigger?
The tabulated value is bigger.
भाई फैसला कर लो आप लोग देख के नहीं बता पा रहे हैं कि 2.52 इज ग्रेटर और 2.58 इज ग्रेटर. मेरे हिसाब से 2 from my side 2.58 is greater. Are you satisfied what I said? 2.52 is less than 2.52 58 2.58. So we will accept it or we will reject it.
Accepted.
Accept, sir.
Okay. You have to. This problem is given to you. The weight of calf at weekly intervals are given below. Age in weeks and weight in kgs. You have to fit a straight line to the above data and then give an estimate of weight for the calf when it is 7 weeks old. Now, any one of you who can tell me this problem is related to what? Which part, under which part these types of problems are asked? अब देखिए ऊपर लिखा हुआ है regression. At the top it is written regression. And if it is written regression, that means you are estimating a future value. 5 weeks तक आपको डेटा दिया हुआ है and it is being asking about the 7th week. तो ये regression है. Regression को solve कैसे करेंगे आप? Column X and Y is given to you. Mute yourself. A column X and Y is given to you. You have to calculate X square and XY. And the least square normal equations have to be used. Summation Y is equal to NA plus B summation X. And summation XY is equal to A summation X plus B summation X square. Values have been calculated in the table. Put up the values, you will get two equations, two unknown. By elimination, find out the value of A and B. And in this problem, it comes out to be 26.1. And for B, it is 3.9. Substitute in the original equation. Y is equal to 26.1 plus 3.9x. Now, what was asked? What will be the weight of the 7 weeks? So you place up x is equal to 7, you will get 53.4 kg. Straight away you can see that. For week 1 it was 30, week 2 it is 34, 3 37, 4 43, 5 45, 6 will be something related to 50, and the 7th is 53.4. When you are being asked to calculate the future value, it is a case of regression. Two random variables have the least square regression lines. 3x plus 2y is equal to 26 and 6x plus y is equal to 31. You have to find the mean values and the coefficient of correlation. Now, हमने regression correlation में जो भी पढ़ा मैं उसको अब मैथमेटिकली आपको कैलकुलेट करके दिखाऊंगा। आपको दो इक्वेशन गिवन है, आपसे क्या मांगा है, मीन वैल्यूज मांगी है, दैट मीन्स आपको यू हैव टू फाइंड x bar, y bar and you have to calculate coefficient of correlation, that is r. Okay, straight away we are simplify these two lines. There are two equations, two unknowns. By the method of elimination, you will find the value of x and y. Here x is 4 and y is 7. Straight away the mean will be, mean of x will be 4 and mean of y will be 7. First part completed. Second part is coefficient of correlation. Now see what I'm doing. In first equation, I'm converting this equation for y on x. So that means I will be putting y on the left side and all the values of x and constant on the y side. Then I will find out byx. In this case, it is minus 3.2. The coefficient of x will be your byx. Yx is minus 3 by 2. Now I will be moving to the second equation. For that, I will be converting that equation for x is equal to y. So at that time, I will be getting bxy. See, it is minus 1.1 by 6. Both byx and bxy are having same sign. Correct? Multiply it. You are getting 1 by 4. Correct? Both the signs are negative. That means your r, for calculating r, what you are supposed to do, r is under root of bxy and byx. Multiply it, you will get under root 1 by 4, which is 1 by 2. 1 by 2 is 0.5. Both yx and xy were negative. Therefore, your r will be negative 0.5. This was taught to you in the theory that bxy and byx will have the same sign, and your answer of r, that means coefficient of correlation, will be with that sign only. Okay. Now, any question from anyone? Any doubt, any problem? Still you have something in your mind? Please ask. Any question from anyone? Or should I conclude the session?
No questions, sir.
That means we can end up today's session. Okay.
Yes, sir.
Okay. All the best for your papers and your future.
Thank you, sir.
Thank you so much, sir.
Thank you.